Astronomy is a pretty cool science. It's not as cool as biology, but still, it's pretty cool. And one of the coolest parts of astronomy, and certainly one of the motivating enigmas of the field, is the search for Earth-like exoplanets that could host potential human colonists, or potential alien life. And on this note, I have some neat science news for you. A team of astronomers were using telescopes at the Gemini observatories in Hawaii and in Chile, and the Kitt Peak National Observatory in Arizona, and they were using these telescopes to double-check stars identified in NASA's TESS exoplanet hunt project. The TESS project, TESS if you want to look it up, the TESS project identified a number of stars hosting exoplanets, and this astronomical research team was following up on each of these stars with exoplanets and doing subsequent observation and analysis. By using the Gemini telescope's higher resolution, they found that 73 of these planet-hosting stars detected by TESS were actually not single stars, but were in fact binary star systems with a previously unnoticed companion star. Specifically, the planets orbited the one star, the one that was picked up by TESS originally, and the star-planet system orbits the other star at some suitable distance where the planet's orbit isn't disrupted. Now this is super fascinating, because before this it was widely suspected that binary star systems are just not suitable for planets. Either the formation of the system precludes planets, or destroys any emergent planets in short order, or perhaps the other star disrupts and destabilizes those planetary orbits. But in any case, it was thought that binaries were poor sites to search for planets because the systems were probably just too unstable, too dangerous. As binary star systems make up about half of all star systems in the cosmos, this means that the estimates for the number of planets in the galaxy were cut down dramatically when this variable was entered into the calculations. The astronomy team estimated that there are likely many planets in binary systems that have gone unnoticed by the TESS project and other telescopes, as the TESS measurements use dips in light to detect planets transiting in front of their star, and nearby stars, like binary partners, can obscure this dip in light. The glare can mask the light dip, and thus the planet, from the sensors. And this was reinforced by the patterns that the astronomers detected in the TESS exoplanet data. You see, TESS found smaller and larger exoplanets orbiting single stars, but the only planets that TESS was able to identify around binary stars were larger exoplanets. And this suggests that either the smaller planets didn't exist around binary stars, or, as this new study suggests, there are smaller planets around binary stars, but we just didn't see them because they were being obscured by the glare of the second star in the binary. Now, the researchers also speculated that the distance between the two stars in a binary was really important. Stars that orbited each other at larger distances may be able to sustain gravitationally stable islands around them, where planets could theoretically form and orbit in stable perpetuity. Stars that orbited at closer distances may be too gravitationally turbulent, precluding the formation or the safety of any potential exoplanets. However, citing the short transit periods that the TESS project used, the researchers said that they couldn't find any clear trend on this particular relationship. Now, I bet that if we do further studies, further astronomical research with higher resolution telescopes and arrays and whatnot, we will find this to be the case, that it's more likely that planetary systems and binary star systems form around stars that orbit relatively far apart, so you do have that gravitational stability. Maybe the evidence proves me wrong, but that's my intuition. That makes sense to me based on my understanding of how the physics and stuff works. The important question is, what does this mean for biology? Well, to quote Katie Lester, lead researcher at NASA's Ames Research Center, since roughly 50% of stars are in binary systems, we could be missing the discovery of, and the chance to study, a lot of Earth-like planets, unquote. So in essence, these astronomers found evidence suggesting that Earth-sized planets may be way more common than we thought, and they may be orbiting stars in a binary pair. Such planets would have two suns in their sky, or more likely they would have one sun and one extremely large bright star that dominates the night sky and probably remains visible during the day. The implications for biology here are super fun. the habitable zone of each star may be slightly expanded due to the input from the companion star. Any alien life on one of these theoretically habitable exoplanets may enjoy more heat and light relative to life on Earth. And in a general sense, in a mathematic, probabilistic sense, the odds for alien life existing somewhere out there in the cosmos on some strikingly Earth-like world, or perhaps some exotic alien world, the odds of alien life existing somewhere out there have improved drastically, as the number of Earth-sized planets in the galaxy may have been greatly underestimated.